In the previous class, we discussed about what work that is. Can you remember about what is actually work in physics or in science? Work depends on two factors. Which are they? That means work W is equal to force into displacement. Work is equal to force into displacement. It is the product of force and displacement. Work is the product of force and displacement. Now, see here the unit of work is what is joule. Joule is the unit of work. And there are two types of works, positive work and negative work. When does the work become positive? Can you remember? If the displacement is in the direction of force, then the work is positive. Example, a person pulling a table. The table is moving towards you. Then the work is what? Positive. Then the frictional force is acting opposite to its motion. Then the work is negative. So work can be positive or negative. Work depends on two factors, force and displacement. If there is any one of these quantities not in this relation, then there is no work. That means if we apply force, then there is no displacement. We cannot say there is work. Now, with this all, we discussed about work in our previous class. Now, we are going to discuss about another new term, that is energy. You want to remember what is energy? To do in our day-to-day life, we require energy. From where we get that energy? We get energy from the food we take. From the food we take, or the food we eat, from it we get energy. But in science, energy is different from that. In our earth, most of the energy we get from where? From the sun. So sun is the natural source of energy. Then we get energy from other sources also, that is from the nucleus. From the nucleus also we get energy. From the nucleus of an atom also we can get energy. And also from the interior of the earth. From there also we get energy. And from tides, there also we get energy. That means these are the natural sources of energy. But you think about energy concept in science. Suppose a body can exert a force on another object, then the first body possesses energy. So the second body which get that force, that get energy. That means actually energy means, energy is the capacity or ability to do work. Energy is the capacity or ability to do work. What is energy? Energy is the capacity or ability to do work. For you, here given one activity, that is, see, a few sources of energy are listed. That means, which are the few sources of energy are listed? Sun, tides, interior part of the earth. From there all we get energy. There are many other sources of energy, list them. Some other sources of energy also you want list. That means energy from waves, energy from wind, then energy from, that means solar energy. These are the some other sources of energy. Then discuss in small groups how certain sources of energy are due to the sun. Some certain sources of energy are also due to the sun. That means tidal energy, that also from sun. And solar energy, that also getting due to the sunlight. Then wind. Wind is also caused by the difference in temperature creating in the ocean, and that causes the sunlight. So that also from sun that we get energy. Here another question, are there sources of energy which are not due to the sun? Are there other sources of energy which are not due to the sun? For example, from the interior part of the earth, from the interior part we get what is some, that means energy from hot spot. That means we know inside the earth in the molten state, and due to that temperature, water becomes a high pressure steam, and where that steam present and that region is called a hot spot. So energy we get it from hot spot, that also not from sun. And also the energy from the nucleus. Energy from the nucleus, that also not from the sun. So we can get energy from other sources that does not depends on the energy of the sun. Now see, actually capacity or ability of a body to do work. Capacity or ability of a body to do work is called actually what is energy. So energy is a capacity or ability to do work. When one body does work, its energy decreases. When one body does a certain amount of work, its energy decreases. And when it do the work on another body, that body get energy. So it energy increase. So you want to remember what is actually energy. Now you want to know different forms of energy. Different forms of energy. Among that, first one, which is that one, mechanical energy. This mechanical energy consists of that means mechanical energy means it consists of potential and kinetic energy. Then other forms of energies are light energy, magnetic energy, electrical energy, gravitational energy. These are the some other different forms of energy. Now you want to remember what is actually energy? Capacity or ability of a body to do work. What happens to the energy when a body does certain amount of work? When the body does certain amount of work, its energy decrease. And on which that work is done, its energy increase. The different forms of energy are mechanical energy. This mechanical energy consists of what is potential and kinetic. Then other forms are what is light energy, magnetic, electrical and gravitational, etc. Now for you, here given on activity. See, the activity given for you, you try to do it in your home. The things you have given, take a heavy ball, that means a massive ball, drop it in a thick bed of wet sand, that means see, this one is a heavy ball, here wet sand, thick bed of wet sand. Then you drop this ball at first at a height of 0.25 centimeter. Then you drop it with a height of 0.5 meter or 50 centimeter. Then at a height of 1 meter. Then 1.5 meter height. That means at first from smaller height and then little bit more. Then again more height, then again more height. In this way, you drop that massive or heavy ball to the wet sand bed. In each case, you want to notice. In each case, you want to notice the depth of the pit here formed. That means here when the ball falls on this, here a pit will form in this wet sand. That means next another pit will form. That means you want to notice the pit one by another and notice when does the depth of the pit is smallest and when does it become largest. These are the questions you are asking to you. Compare their depths. Which one of them is the deepest? Which one of them is the deepest? When the ball dropped from a height of 0.25 centimeter or when it dropped from a height of 1.5 meter. When does the depth of the pit become? That means large. When does it becomes? When it is dropped from a height of 1.5 meter. The 1.5 meter, it becomes a pit, become the deepest one. Then another question is given. Which one is the shallowest? Why? Which one is the shallowest? When the ball dropped from a height of 25 centimeter or 0.25 meter. 25 centimeter or 0.25 meter. 0.25 meter. Then what has caused the ball to make a deeper dent? Discuss and analyze. What has made? See, when you drop a ball from different height, that ball possesses energy. That ball possesses energy due to its motion. When it dropped from a height of 0.25 meter, 0.25 meter, the pit formed here is the shallowest, because at that time the energy possessed by the ball is very less. But when we drop it from a height of 1.5 meter, the energy of that ball due to its motion becomes very large. The energy of the ball due to its motion becomes large. So the pit formed here becomes deepest. So the pit formed here is the deepest one. Now another activity also here given for you. See, which is that activity. On the table, we made a pulley here on toy track. And here on wooden block, and this one is connected with a string, and at its ends there is a pan, and in this we can hang weights. Put a weight. When we put a weight on this toy track moves, and when it moves and on its way there is a wooden block. By hitting this wooden block, that moves to a certain distance. That means this moving toy truck hits this one, and this wooden block is displaced. And when we put here more weight, the displacement produced here becomes small. Why? This wooden block is displaced here means because this moving trolley, this moving bus, that possesses energy. Some questions to you. From where does the energy come? From where does the energy come? From the motion of this body. That means motion of this body produces what is this energy? And another question is from first question is from where does this energy getting to move this block means due to the motion of this what is toy truck or bus. Repeat this activity by increasing the mass on the pan, in which case the displacement is small. When the mass is small, here the displacement becomes small. Then in which case is the work done more? When the mass increase, and so the speed of this one also increase, so the work done becomes more. In this activity, the moving trolley does work and hence it possesses energy. So moving trolley or moving truck or toy truck or trolley, that possesses energy. So it does work. From this what we get, a moving body also possesses energy. Moving body possesses energy. From the above two activities we can come to when a body moves, that possesses energy. And that type of energy is called kinetic energy. And that type of energy is called what? Kinetic energy. What is actually kinetic energy? It is the energy possessed by a body due to its motion. It is the energy that having a body when it moves is called what is kinetic energy. For example, when we shot bullet from a gun, that gun can pierce thick wooden block because that possesses energy. And when we hit nail with a hammer, that hammer possesses energy due to its motion. And see, when a moving cycle hit on a person, that person gets injury because of that moving cycle. Bicycle has energy. So from this all, whenever a body is under motion, that possesses energy, and that energy is called kinetic energy. What is called? That energy is called kinetic energy. Kinetic energy is actually energy due to motion. That means due to the movement of a body that has energy, and such type of energy is called what is kinetic energy. Kinetic energy is the energy due to motion of an object. You know, actually energy is the capacity to do work. So the unit of energy, and work are the same. What is the unit of work? Say, what is the unit of work? Yes, it is joule. Here the unit of energy is also joule. The unit of energy is also joule. Now we want to get an equation to calculate this energy. Which is this energy? Kinetic energy. Kinetic energy, can a body possess when it is at rest? Suppose this duster is on the table. Is it now possess kinetic energy? No. Why? Because it is not under motion. Kinetic energy is only when there is motion, or when a body is under motion, or when a body is moving, then only it possesses kinetic energy. Now we can find out the relation connecting kinetic energy. See, consider a body of mass m. Consider a body of mass m that is moving with a velocity u. Then a constant force F acts for a time t. Then a constant force F acts on it, and it produces a displacement S. Consider an object of mass m is moving at a velocity of what is u. Let a constant force F acts on it for a time t. Then the displacement of it becomes S. Now its velocity u changes to v, and the acceleration produced is a. Once again, consider a body of mass m. Its initial velocity is u. A force F, what kind of force? A constant force F acts on it for a time t, and it produces a displacement S, and then the velocity u changes to v, and the acceleration that produced a is uniform. Now from see, what are the things we discussed here? What is actually m? Mass. U, its first velocity. F, constant force F acts on it, and for a time t. Now the acceleration produced is a, and displacement is S, final velocity v. These are the things happening. Okay, we know the relation F is equal to, that means we know work is equal to force into displacement. We know work is equal to what is actually force into displacement. Now from this equations of motion, we can take the relation b square minus u square is equal to 2as. From the equation of motion, V square minus U square is equal to, we know what is a 2AS. From this, S equal to what? That is equal to V square minus U square by 2A. This is the displacement S. How much it is? V square minus U square by 2A. Now we know work W is equal to F into S. But W is equal to F is equal to mass into acceleration A into S. So M into A into S is how much? V square minus U square by 2A. This A we can cancel. So what will get? That is equal to this to half M into V square minus U square. We know the work done is the change in kinetic energy. So kinetic energy K is equal to half M into V square minus U square. So work done is equal to change in kinetic energy. Work done W is equal to actually what is K, and it is equal to what is change in kinetic energy. W is equal to K, that is equal to half M into V square minus U square, that is equal to change in kinetic energy. Change in kinetic energy. Okay. See, if the body was at rest in the beginning, then U is equal to 0. If the body remains at rest when the time starts, then U is equal to 0. Then the relation become K is equal to what? This term is no more there. What will get? Half M V square. What is the? K is equal to half M V square is the relation to find kinetic energy if the body was at rest in the beginning. Okay? This relation we can use to calculate kinetic energy, which is the relation K is equal to half M V square. From this we can find out kinetic energy. With this, there are some numerical problems given. Let us do it. The first question here given is an object of mass 15 kg. An object of mass 15 kg is moving with a uniform velocity of 4 meters per second. What is the kinetic energy possessed by the body? What is the kinetic energy possessed by the body? An object of mass 15 kg moving with a velocity of 4 meters per second. What is the kinetic energy possessed by the body? We know kinetic energy, that means energy E, K is for kinetic. E is for energy and K is for kinetic energy. Is equal to what is the relation? Half M V square. Half M V square. That is equal to half M. How much? 15 into V square. V is here 4. So V square is 4 square means 4 into 4. Now this we can cancel. 2 will get. 2 into 4, 8. 15 times 8. How much it will be? 15 times 8. How much it will be? It will be just you want to multiply. Then how much it will get? It is equal to 120 joule. This is the work done. And also it is equal to kinetic energy. Now the kinetic energy of that object is 120 joule. Now another one problem. What is the work done to increase the velocity of a car from 30 km per hour to 60 kilometer per hour if the mass of the car is 1500 kilogram. What do you want to find out? What is the work done to increase the velocity of a car from 30 kilometer? 30 kilometer per hour to 60 kilometer per hour, and the mass of the car is given 1500 kg. See, its initial velocity u is given here. How much? 30 kilometer per hour. That is 30 into kilometer we can change to meter by multiplying with 1000, and this hour is changed to second, 60 into 60. Then how much it will be? On 0. That means 300 by 36. U is equal to 300 by 36. Here will come. Again we can divide with this once more. See, this 5 times 6 here on. 5 into 10, 50 by 60 cc. That means 5 into 10, 50 by 6, 8 times 48. 2. Put in decimal, 23. Again 80. 2. So its speed u is equal to 8.33 meter per second. This is the initial speed of the car, and it changes to 60 kilometer per hour. So its final speed, let us find out it also. V is equal to 60 into 1000 by 60 into 60. This 60 we can cancel. This one 0, 100. Then how much it will come? 50 by 3. This 2 times 3, 6. That is how much? It is 16.66 meter per second. This is the final velocity. What actually we want to find out? We want to find out what is the work done to increase the velocity of the car from 30 km per hour to 16 km per hour. That means we know work done actually equal to change in kinetic energy. Work done is equal to actually what is change in kinetic energy. So that we can find out change in kinetic energy. How we can find out? Work done is equal to change in kinetic energy, that is half m into v square minus u square. That is equal to half into m, 1500 into v square. That is 16.66 square minus 8.33 square. This we can find out, first of all we can find out 16.66 square minus 8.33 square. Then we subtract and multiply with this half into 1500. Then the value of this we can get it. See, when we subtract these values, its answer we get, that means change in kinetic energy, that is equal to, how much we get? That is 15,156,375. Joule will get it. 156,375 Joule. That means 1,56,375 Joule energy is the work done here. Work done is equal to change in energy. That means 16 square minus 8.33 square. First you take 16.66 square. From that 8.33 square you subtract. Then you multiply. Then you can get the value as how much? That means 1,56,375 Joule is the work done there. Now, another question here given. From page number 152. What is the kinetic energy of an object? Kinetic energy of an object. Kinetic energy means energy possessed by a body when it moves. Here question is, what is the kinetic energy of an object? Kinetic energy of an object is the product of, that means E is equal to half of its mass and velocity. A body of mass m moving with a velocity v, its kinetic energy is how much? E is equal to half m v square. E is equal to half m v square is the kinetic energy of that body. Now another question. Write an expression for the kinetic energy of an object. We know kinetic energy is the energy possessed by a body due to its motion or by virtue of its motion, and the expression for it is E is equal to how much? Half m v square. E is equal to how much it is? Half m v square. Now, question number third one. See, the kinetic energy of an object of mass m. Mass here given m. Moving with a velocity of 5 meters per second. Moving with a velocity of 5 meters per second. What is its kinetic energy when its velocity is doubled? When its velocity is doubled, then it becomes 2v. And what will be its kinetic energy when its velocity is increased 3 times? That means velocity becomes 3v. These are the things we want to find out. We know kinetic energy is equal to what? Half m v square. We know the relation. Kinetic energy is equal to half m v square. See, in the first case, it is moving with a velocity of 5 meters per second. In the first case, it is moving with a velocity of 5 meter per second. So its kinetic energy, we know the relation K, that means Ek. Kinetic energy is equal to half mv square, and it is equal to half m into mass is m and velocity is 5. So 5 square. So this, how much it will be? That is equal to half into, that is 5 square is 25 and its half is how much? That means 5 into 5, 5 square 25. 25 divided by 2 is how much? It will be 12.5. 12.5 m joule. This is the kind of, or otherwise we can write half m into 25. Now the velocity is doubled. V is 5. So 2V becomes 10. Double means 10. Now the kinetic energy Ek is equal to half into m into V. That means 10 square. That is equal to half m into 100. 100 divided by 2 is equal to how much? 50 m joule. Now see, at first kinetic energy is 12.5. Now the kinetic energy is 15 m joule. This 12.5 when we multiply with 4, we get to how much? 50. So here when the velocity is doubled, kinetic energy becomes 4. Here velocity doubled, that means 5 become 10. Kinetic energy becomes 50 m from 12.5 m. That means this kinetic energy becomes 4 times. What we can get from this, if the velocity of the body doubled, then its kinetic energy becomes 4 times. Now another term, when the velocity becomes tripled, that means 3 times, we can find out the kinetic energy. Ek, that is equal to half m into 3v, that is 50 square. That is equal to half into m into 15 square is 225. Again, divided with 2. Then Ek, that is kinetic energy, is equal to 225 by 2 means how much? 112.5 m joule. See, now the kinetic energy at first it was how much? 12.5. When the velocity this becomes 3 times, this kinetic energy becomes 9 times. When the velocity increased to 3 times, kinetic energy now becomes 9 times. Kinetic energy now becomes 9 times. So the things we discussed are what is actually energy? Can you remember what is actually energy? Now one more question to you. Does energy is required to do work? Yes or no? Which answer you will select from this? Does energy is required to do work? Answer is yes. If you are giving yes, why? Does energy is required to do work? You selected yes. Then why? What is the answer for why? Because energy is the capacity to do work. So its answer is getting energy is the capacity to do work. Now another question to you. What is the unit of work and energy? If the unit of work and energy remains the same, if the unit of, we know the unit of work is joule, then what is the unit of energy? What is the unit of energy? It is also joule. Why? The unit of energy is also joule. Why? The unit of energy is also joule. See, when we write a unit of energy, for example, kinetic energy, we got the energy and its a unit as joule. See, we know these two get the same unit because work done is the change in kinetic energy, or when we spend energy there is work. So actually energy is changing to work, so both of them got the same unit. This unit is selected in the name of James Prescott Joule. James Prescott Joule, a scientist who gave so many contributions to the science. So Joule is taken. Now see, what is the relation or what is the equation we using to calculate kinetic energy? What is the equation? That is equal to kinetic energy equal to, what is that relation? Kinetic energy is equal to half mv square. This is the relation. If you write the unit of this one, what will get? A unit of mass kilogram. Velocity, that means meter per second square. Meter per second. So if this meter square per second square. This actually this unit we took as a joule here in the name of the scientist James Prescott Joule. Now, what is the relation connecting work and energy? Work done is equal to change in kinetic energy. Work done is equal to change in kinetic energy. Now, we also discussed about different forms of energy. Among that one is mechanical energy. That mechanical energy consists of other two energies. Which are they? One is kinetic energy that we discussed here, and another one is potential energy. And other forms of energies also we know. Which are they? Electrical energy, then light energy, sound energy, then magnetic energy, solar energy. In that way we can get different other forms of energy. Now we discuss about different forms of energy and in detail about kinetic energy and a relation which we can use to calculate kinetic energy Then from this unit we discuss about work. We know work as the product of force and displacement, and it is a scalar quantity. That means it has only magnitude, no direction. Then the relation connecting work and energy, and some activities to find this energy. That means how certain case work is doing. For example, a ball falling, that means a massive ball falling to the wet sand, the dip formation, that is due to the moving that ball possesses energy. Another one is trolling, that also when it moves the wooden block, it is also due to the energy possessed. Okay, with this all we can conclude today's class. Okay, thank you.